Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adam Mohaimin. We are from Group K. Today we are going to present assignment 2. Without further ado, let's begin. Okay. In this assignment, our group developed a supervised learning model using the BIMA Indian Diabetes dataset. There are several primary objectives for this assignment. Firstly, we want to implement a neural network classification algorithm, which is NLP classifier, by using the Python. This one to make sure that we can classify the patient that have diabetes and the patient that does not have diabetes. Secondly, we aim to evaluate the model using cross-validation and performance metrics. This to ensure that the model has a better accuracy after the process of training. Next is the platform. The platform we use for programming is Google Colab. We use Google Colab to implement neural network algorithm because Google Colab is free for all and it is user-friendly and everyone can use it. So next, our friends will explain all the codes in Google Colab.
Assalamualaikum warahmatullahi wabarakatuh. I am going to explain to you our Python code. So let's start with the first paragraph first. So of course we need to upload all the core libraries, the visualization tools, sklearn tools, and everything that we need for our project. So after we have done that, of course we need to upload our CSV file. So this diabetes.csv file we downloaded from Kaggle, but we believe that it's also in UCI database. And so then we load the CSV file here. So this code here we load into pandas data frame, which allows us to easily manipulate and analyze the data. Here we load the CSV file into a data frame and display the first few rows to inspect structure. Okay, so the df head here shows the first few rows of the dataset to give us overview of the data structure, making sure there are no immediate issues like missing columns or misformatted data. So it looks okay here. It looks okay here, but if you read the spreadsheet, if you go through the Excel file, you will find that some columns, such as glucose and insulin, BMI, they have zero values, which not supposed to be zero because glucose cannot be zero, BMI cannot be zero, but there are zero values. So here, we check for zero values and we replace the zero values with a median here. So the calculation will not be invalid. So after cleaning the data, we separate the features, the input features from the target variable outcome. So we have many columns, right? The last column is outcome column, which we are trying to predict. The outcome column represents whether the person has diabetes 1 or not. Okay, here we split the features per labels. Okay, so and then we apply feature scaling using standard scaler from scikit-learn to normalize the feature values. This step is very important because neural networks perform better when the features are on similar scale. Okay, here. So then after we have done that, after scaling the features, we split the dataset into training and testing set. The training set will be used to train the model, and the testing set will be used to evaluate its performance. So here we set the test size to 20%, okay, which is normal. So for the machine learning model, we chose NLP classifier AS. We have learned in the class. Okay, so it's feed-forward neural network, consists of multiple layers of neurons as well as binary classification tasks. Okay, and we configure the NLP with two hidden layers. The first hidden layer has 50 neurons and the second has 30 neurons. Okay, we set the maximum number of iterations to 1000 to ensure the model has enough time to converge. So once the model is trained, we evaluate the performance using several key metrics. So one of it is confusion metrics, as you can see here. So confusion matrix shows the counts of true positives, true negatives, and false negatives, allowing us to assess the model's ability to classify the two classes, diabetic, which is binary 1, or non-diabetic, which is binary 0. Okay, here, and you see the confusion matrix, it gives us the precision we call F1 score and accuracy score. So you can see here the accuracy is 69.5. Okay, so the confusion metric helps us visualize whether the model made correct predictions or whether it made errors. Okay, so the second evaluation technique is we use 5-fold cross-validation. Okay, cross-validation is to ensure the model performs well across different data subsets. We use 5-fold cross-validation. This method splits the dataset into 5 parts, trains the models on 4 parts, and tests the remaining part. This is repeated 5 times, and the average accuracy is calculated. Okay, so cross-validation technique helps us understand how the model might perform on unseen data and prevents overfitting by ensuring the model generalizes well across different subsets of data. So our final step in the analysis is understanding which features is the most important in making predictions. Okay? So we use permutation importance to measure the importance of each feature by evaluating the change in model accuracy when the features values are randomly shuffled. Okay? So features with the largest importance values are the most influential in the model's decision-making process. The chart here, generated from this analysis, reveals that glucose, diabetes pedigree function, and age are the most significant features for predicting diabetes. So for our performance results, as I mentioned earlier, the accuracy score is around 69.5%, which is decent for a baseline neural network. The precision recall for non-diabetic patients were higher, but diabetic patients class 1 had lower recall, meaning the model missed several diabetic patients. Okay, so these suggest areas for improvement. So that's all for our code. I think I've explained all the parts. Okay, so that's all from me. Thank you.
Okay, my name is Mama Iman. I will present about conclusion. From this project, we use MP classifier model. The MLP classifier achieve 99 accuracy and perform consistently well. Neural network prove the efficiency in learning from the standardized health data. The analysis identify 3 primary predictive factors, which is diabetes for the diabetes, which is glucose level, diabetes pedigree function, and patient age. Next is lesson learned. From this project, we master the architecture and mechanism of the neural network. After that, we develop a function that understanding of backpropagation and gradient descent. Hand-on implementation, we successfully built and trained the MLP classifier using Python, scikit-learn, also real-world medical data from PIMA Indian diabetes dataset. Lastly, group contribution. Adam Mohaimin are responsible preparing the report and compiling the video, while Bashar conduct the experimental evaluation and result analysis and implemented the neural network algorithm, while me focus in the finding the PIMA Indian diabetes dataset. Okay, that's all from me.